Hello everybody, today we're going to be proving that the function going from the real numbers to the real numbers defined by f of x equals x cubed is bijective. By the way, bijective means it's both surjective and injective. Okay, so let's get straight into this proof. So, first of all, we're going to have to prove that it's injective. So let's do that. Injective. Okay, so to prove that it's injective, we need to show that there exists an x and y. Okay, so suppose that x and y are in the real numbers, and by the way, these x and y, they need to be in the domain of the function, which is here, which is the real numbers. So we need there to be an x and y in the domain, and f of x equals f of y. So if f of x equals f of y, where x and y are in the domain, we need x to be equal to y. Okay, so let's do this. So if f of x is equal to f of y, that is, what does this mean? It means x cubed is equal to y cubed. Okay, so now if we take the cube root, we get that the cube root of x cubed is equal to the cube root of y cubed. Now what's important here is we need to notice that the cube root of any value, that's always going to give you one answer, okay? So the cube root of 8 is going to be 2. It's not going to be minus 2, because that will give you minus 8. So that's important here, okay? So we know that the value of this, there's just going to be one value, and that's x. And for cube root of y cubed, it's y. If this was x squared, it would be different, because that will give you the plus or minus square root, so that would be very different. Okay, and that actually wouldn't be injective, but this is. Okay, so we've shown it's injective now. So now we need to show that it's surjective. So we need to show that it's surjective. To show it's surjective, we're going to say suppose, and we're going to say suppose that there is a b, there exists a b in the codomain, okay? That's the codomain of the function, which is still the real numbers. So suppose there exists a b in the codomain, which is the real numbers. And then we're going to say let x equal to, and we need to find an x such that when you take the function of x, it gives you back b, okay? So we're going to say let x equal to the cube root of b, because if we do this and then we cube this, that will give us b. So that's the for process. So now we're going to say then f of x is equal to f of the cube root of b, which is simply the cube root of b cubed, which equals b. Okay, very nice. And now we also needed our x to be in the domain of the function, so we're just going to quickly say notice that the cube root of b is in the real numbers. Okay, if this was, say, x squared, say if we had x equal to the square root of b, then we couldn't say that that's in the real numbers, because what if b is negative, you know? That would be an imaginary number, it would be a complex number. But here, this is always going to be in the real numbers. Oh, sorry about that. So we've shown that x is surjective and injective, so now we can just say since f is both injective and surjective, because that's what it means something to be bijective. It has to be injective and surjective. So since it's both injective and surjective, f is bijective. So that is the proof today, and thank you for watching. And if you like more of these proof videos, please leave a like, leave a comment down below on what videos you want to see next, and thank you for watching. Goodbye.